Hi, my name is Dennis. I'm doing a electrical engineering project that's based at Clark College for my end of the year project. So what I designed here was it's a solar tracker. So essentially, the system I designed was to capture the sun's rays in the optimal way. So instead of just having a static solar panel, I wanted to create a system that would follow the sun and capture the energy as the sun moves from I believe east to west. Maybe wrong there. And so the major components I have here was the Arduino here. That's what the code is run on, paired with the proto board. 3D printed parts. This was a major part. I used a program called Tinkercad to design both the gears and the gear base and the mount for the solar panel. I used Clark College's 3D printer to print out all these parts. To run the movement, I have a vertical servo motor in there that controls the vertical movement. Let me show you. Controls a vertical movement, and you can see a couple gears back here and how everything's attached. And then I have another motor that controls the horizontal movement. And so I just want to demonstrate how this works. And so this right here, we're just going to hit the reset. And here it's tracking the most optimal light levels in this room. And right now it's saying that this position is the best in the room, and so we can see by watch the voltage as it stabilizes in the most optimal position. So say if I move my hand over the light dependent resistors, it will try to move away and find the most optimal position at that point. One of the couple improvements I wanted to make that just granted not enough time was I have the solar panel connected here to just my voltmeter here. But what I really wanted to end up doing was actually have it power something. So components, something like an inverter, charge controller, and some batteries. And you could actually make a system to where you could take the sun's energy and actually hold some charge and be able to power something. The other improvement I wanted to make was this. Obviously, the module that we have here it's not large enough to actually power anything useful. So the next step, I think, in this project would to be build like a large scale version of this, something like a 200, 300 watt panel, using the similar design. And then using the components, so for inverters, batteries, you'll be able to make a system that can capture the sun's energy optimally and actually power something. Yeah. Some of the let's say major challenges I had was the code for the Arduino. The first big challenge I had was I wanted to use the actual solar module to see how much light's coming in, and then use just the module itself to adjust. And the code did not work out very well, so I switched over to four different photoresistors or light dependent resistors. And as can be seen here, I have a little system here that it's a little cross that kind of separates all the light dependent resistors from each other. That way light does not bleed from one edge to the other. code, I have the top averaging with the bottom, averaging with the left, averaging with the right, to see where the most level light is coming in. But other than that, if we have more time, I'd like to build my large scale one. That's the next step.